right? Yeah. So we were solving problems from Artin, basically the first section of the first chapter. Yeah, basically elementary matrix problems based on that. And that Virendra, the linear algebra that you're reading, that will be very useful for that. Okay, so it's like concrete version of linear algebra which you are reading and will be reading more. But we will not continue with Artin's problems because we have sort of solved the first section, first 15 odd problems. So today I planned that there was this entrance exam, CMI Data Science. Okay, so I'm not interested particularly in the entrance itself, but the questions which are matrix based on matrices and linear algebra, those questions I found are good for us. Okay, so we should just try them. So that's what I will do today. We will not do much, so we'll just let's begin. Yeah. And I think in the last Tuesday's class on this, I had given some questions. We can address them towards the end if you can remind me. Okay. So this will be CMI Data Science, okay, 2022. But we will do the questions of matrices. If you're interested, you can try the other problems also. But yeah, to be systematic, we will do questions on matrices. So problems on matrices. Yeah. So with that being said, let us begin. I have also not seen these questions, so we will do them together. Yeah, right. So this is question number. Okay, let me not worry about the number. Let's just read the question. Yeah. So so the question is, A and B are invertible n by n matrices. Okay. Okay. And C is, which is defined in this way. Okay. So you know what transpose is? It's A transpose. And D is defined in a slightly more complicated way. B, A transpose, B transpose. Okay. Okay. Now, what can you say? So this is given to you. That's all that's given. And question is, what can you conclude? So there's basically option. You need to say if it's true or false. Okay. A, B inverse. Can we say that it is equal to identity plus B inverse A inverse? So is this true? Just let us think about this. Okay.
Okay, sir.
Yeah, this is easy. This option is easy. I've written down all the options and you have to see which one of them are correct. There can be multiple correct. Okay.
Sir, I mean, what tools I can think about? Can you
The
guide
most
me?
basic, the most basic things. These questions are very basic. The most basic things. So the very first thing that you see is AB inverse. So this is inverse of product of two things, right? So
Okay.
what do we know about this? What is this equal to,
Okay. B inverse A inverse.
right? So we know this fact. So I'll just talk about this fact for 2 seconds, 2 minutes. Okay. That so this fact is something that is universally everybody should know. This is nothing. This thing. Okay. And this fact is more general, right? So let me mention it in that general setup. Okay. So that S is a set. Okay. Circle is a binary operation. Binary operation. Okay. And E is identity. Okay. Identity meaning with respect to the binary operation. So what this means just is this is equal to this is equal to A. So it doesn't change the element. So that you know, so I'm using that. Okay.
Yes.
Now, yeah, if A and B are invertible, okay. So you know what this means. This just means A
A
times
into
right. So there is some inverse. There is a C such that this is equal to identity, and also obviously we need this. Okay, that's what invertible means. The C is the inverse. We usually write it as A inverse. Okay, so let me just say A and B are invertible. Means that there is a C such that this happens. Okay. Then AB here means this. Okay, is also invertible. Right. So why is this true? It is true simply because you can find an inverse. And what is that inverse? Let us say that the inverse of A is equal to C. Usually we call it A inverse, but I'm just calling it C. Okay. And inverse of B is equal to D. Okay. So this means that I have this C and D, so I will use them. So they are our candidates. Okay. And so how will I use them? I will use them like this. I will prove that this is equal to identity. So can you people do that? Right. The claim is that this is equal to identity. Yeah.
sir.
Yeah.
So it
Nagesh,
is a
please
binary
try this.
operation.
Sorry.
Sir, binary operation is associative.
Good question. Yeah.
So
So that's why my question is wrong. I should say it's associative. Correct. That is what I was anticipating. Yeah. So without associative, all this is not true. Right.
yes, sir.
Right. Now can we do it?
Associative.
Yeah.
Uh,
So now it is very
yes, sir.
simple, right? Yeah. Now you just
B
do
into
this.
D and yes,
Right. So B into D is E. And just step by step we go on.
we get identity.
Okay, and the other way also you have to check that the other way also you have to check, otherwise the proof is not complete. Okay, right. So that's it. So you have to check this. All right. So we have shown in general, right, that the inverse is that the product is also invertible, and we know what its inverse is. This is true for any set with binary operation. Okay. In our case, the set is the collection of all in correct. Actually, you are correct. Collection of all matrices. Right. You don't need collection of all invertible matrices. Just collection of all matrices. That's fine. That is the same fine for us, right? Collection of all matrices is our set S. Multiplication is binary operation. We have spent time in proving this earlier. Maybe Virendra was not there, but it's a fact which you can prove that the matrix multiplication is associative. Yeah, and then this is true. So this is all. This is as clean a fact as you can expect, right? And this is not surprising by any means. You can take examples. You can take practical examples. You can. This fact has to be known. And okay. So now is number 1 correct?
No, sir.
Yeah, it's certainly not correct, right? Otherwise, I will become 0.
Yes, sir.
Right. So it's like a silly question, right? And if you just know the fact, then this is a silly question by all means. So this is because we know this is this, and if this is true, then I is 0. So by all means, this is wrong. It's just yeah, strange to even ask this. What about 2? Yeah.
Sir, for some condition it is true. I mean, if the group if group is abelian, then it is true. Then in matrices, I mean, if, like there must be something that it must be true.
Okay, so I know you a lot of things are going on in your head. You are thinking, but the question is very simple here. Okay, you need to answer the question. Okay, so if you just want to answer the question, then the question is A inverse B inverse equal to B inverse A inverse for all A and B, for all invertible matrices? Because that is what being true means, right? A and B are given in general. Is this true? Means is it true for all A and B? Because nothing is said about A and B. Okay.
Okay, sir. No, it is not true, sir.
It is not true. Answer is no. Done. Right. Then of course we can talk when it is true, when it is not true. Those are very interesting questions. But yeah. So this is not true. An example, you take any 2 matrices, most probably it will not be true. Okay, if you just So because A inverse is just a matrix C and B inverse is just a matrix D, and so you're just asking this. And A inverse is not a special matrix. Every invertible matrix is inverse of some matrix. So this is nothing special that it will be suddenly be true. And you can so when I say no, I should give you a counter example. Otherwise, no, how, but we know it is no. But if you have to write, then you have to produce a counter example. But of course, here you know, so it's not a problem. Okay. Whenever you say something is not true, it means that there is something for which it is not true. And so you have to produce some example. That's called a counter example. But you can do that. So they're not. So this is also wrong. See, these questions are as simple as they get. This cannot be any simpler questions in matrices, right? If you think about it. Yeah. Now, what about question C? This is also very simple, but let's do. Nagesh, is it clear so far? Everything? Any questions?
Yeah, it's clear.
Okay,
Yeah.
right. Is it going to rain here? The weather is suddenly cool.
Here also.
Okay. So Virendra, you are original, like where is your hometown?
Sir, Laptur.
Sorry?
In Maharashtra, Laptur district. Are
No,
you aware of
Nagpur.
Laptur?
Can you spell it?
Latur.
Latur. Latur. No, I don't know. There's some other more popular name means nearby.
Sir, Nanded,
Sorry, I don't know. What is the state?
Maharashtra.
Okay, Maharashtra. Okay, so that I should know what I don't know. I know Thane, I know Mumbai, I know what. I don't know much. Yeah.
That is only Konkan part and Paschim Maharashtra part. It is middle of India.
Oh, Eastern Maharashtra, you mean, right? No, Western.
Yes, sir.
Eastern?
Eastern.
Eastern. So
Eastern.
you're more towards Andhra Pradesh also.
More towards Andhra Pradesh and Karnataka.
Yeah, that's why you don't you don't sound like from like maybe, yeah, seems like a mixture of yeah, like
Sir.
Andhra.
Okay.
Yeah, parents are from Andhra or something.
No, sir. In my home, we talk in Kannada.
Okay, Kannada. Okay, so you're Kannada. Yeah, then that's fine. Yeah, I got it. Yeah. Okay, like I'm in Kolkata, but I'm not from Kolkata. I'm from UP. Yeah. Anyways, this is just a side discussion. It's just interesting to try to understand these things. Yeah. Okay.
Sir, sir, if I take C transpose, so is it C transpose, does this make any difference to A into A transpose raised to T? I don't know that. Does that
Okay.
also change?
So you just want to compute C transpose, right?
Yes.
Right. So then what is your question?
I plus A. So, sir, it should be I transpose plus A into A transpose raised to.
Right. We know these things, right? I mean, we all know this thing. This is just how transpose works. And then
Then I transpose is I plus, sir, now I'm confused. Like, is it A transpose into A or A into A transpose?
to think. So if I give you two matrices X and Y, so what is XY transpose?
So it is X transpose into Y transpose. It
Is
does
it?
not make sense.
Can you take some example and see?
Okay, let me check.
Yeah.
A, B, C, D.
Nagesh, what do you think XY transpose? Yeah.
Yeah, it's
Is it? No, can it be this? No, I don't think it is this. It should be the other way, right?
Yes,
You guys don't know
sir.
it? Okay, you should know this. Just read the basic things on facts and matrices. This is not true. This is the other way. It has to be the other way, right? Just think about it, right? It has to be the other way. Yeah. Prove it, please. Please prove it for homework. Don't skip it. Prove it. Okay. Proof. Proof is very simple. Meaning just take some examples to begin with and then just write a proof. Right? Yeah. So in that way, you see, we'll move to the question, but in that way, adjoint, sorry, this transpose and inverse, they are similar in that sense, right? They behave in this anti-commutative sort of way, right? Right. This is a very interesting thing that happens, right? They behave in this anti sort of way. Okay. So, right. So there are deep reasons. There are good reasons why this happens. Okay? But we will talk about them. We cannot talk about them now. Maybe. Okay. Yeah. Anyway, so this is true, and you should prove it. How do you prove it? Well, just multiply it and prove it, right? Yeah, that is one bad way. There are better ways, but anyways, yeah. So if that is in
Option
hand,
D.
huh?
Option D is correct.
Yeah, C and D both are correct, right? C is
C
also
and D.
correct. C and both are correct, right? Okay, so one more thing that I want to say is that, which is, I suppose this is very, very obvious. That is just A.
Yeah.
This or X. Yeah. So basically, this again inverses are also like this, right? If you do them twice, then you come back to the same thing. Okay, so this is like, so these are like operations on matrices, right? These are like, what do you say, unary operations, right? So you can think about it in this clean way, right? That you have matrices, collection of matrices. See, I'm just telling you these things, and you have to later on you have to think about these things. Or if you're googling, you can read. Or if you're reading from a book, then probably you won't find these things now. Maybe later, or I don't know. Yeah, but I'm just trying to tell you that we have this collection of matrices, right? And we want to understand them. Okay. So obviously we have binary operations. That's one way to understand. But also these are unary operations, right? Like inverse is a unary operation, which of course you cannot do on every matrix. Every matrix does not have an inverse. But on a sub collection of invertible matrices, you can do this operation. You can do this unary operation, which just takes one thing and returns. Okay. It's like just like a function on the collection of matrices, two collection of matrices. And this transpose is also like that, and they have these nice features. Okay, and then it is just trivial, right? So you just do this, and then this becomes A transpose transpose and transpose, and A transpose transpose is A, and so it is. Okay, that's it, right? So yeah, that's all. So C and D are, C is correct, then D is also correct. Okay. So what is going on here is actually what I can tell so far is what is going on here is a way to create symmetric matrices. Okay, these are ways to create symmetric matrices. Okay, again, you can I will suggest that right now, since you're not going to linearly reach there in a book, okay, you can just read more from Wikipedia after what I say. Okay, just can look at it. But first, let me say a few things. Okay, so this question is basically saying that is C and D, or are C and D, or just is C symmetric? Okay, like that is just what the question is, right? Is C a symmetric matrix? Okay, now symmetric matrices are extremely important. You know, symmetric matrices look good, they're symmetric, right? On diagonally they are symmetric. Aij is equal to AJI. They have good properties, but they are also important from some other reasons. So symmetric matrices are basically matrices which stand for um, inner, so which stands for dot products. Okay, if you want to have some kind of a dot product, so what is a dot product? A dot product is, you know, right, it takes two vectors and gives you one scalar. Okay, and it tries to compute angle, it tries to compute distance, right? That is what dot product is, right? A symmetric matrix is actually a way to calculate dot product, because if you have a symmetric matrix, or actually if you have any matrix, then you know that if you give a column vector here and you give a row vector here of suitable dimension, then you're going to get a number, right? So this is like calculating the dot product of two vectors, okay, which you will see later in bilinear forms and so on. And symmetric matrices actually calculate the dot products. If you take any matrix, you won't get dot product, but symmetric matrices, you need nice symmetric matrices, but roughly that is what happens. Okay, yeah. Now what was I saying here is that the question is that is C a symmetric matrix? So now you see, always A transpose is symmetric, right? This is always true. It doesn't even have, it has nothing to do with A being invertible. It has nothing to do with A being a square matrix. This is symmetric, you should prove it. Okay, we have basically proved it, but you should prove it again in the sense that I'm taking A being an M by N matrix. And then I'm claiming that this is a symmetric matrix. Okay, should prove it. So this is actually a way to create symmetric matrices. Okay, later on you will prove that basically basically any symmetric matrix can be written like this. Okay, if it's a nice symmetric matrix, I mean not any, but nice symmetric matrix, which is meaningful, a geometrically meaningful symmetric matrix can be written like this. Okay, that's a beautiful fact. Like any symmetric matrix can actually be written, factored into A transpose. So this is a nice way to produce symmetric matrices. And then you can obviously show that if A and B are symmetric, right, that implies that A plus B is symmetric. Correct? You can prove these things, right? A times B is symmetric. Wait, is this correct? Is A times B symmetric? Because I'm a little off of that. No, A times B, I'm sorry, A times B is not clear if it is symmetric. That needs commuting. Oh, sorry, so they don't form an algebra, they don't form, you cannot multiply them. But yeah, the sum of symmetric matrices is symmetric. So symmetric matrices themselves are like, you can add them and you can multiply by scalar, of course. So this is all that is going on here. This is a symmetric matrix, this is a symmetric matrix, sum is symmetric matrix. Obviously, I'm just restating what we have proved so far, but I'm just trying to tell you that look out for these things, okay? Whenever you are trying to prove something is symmetric, or you should try to show it is of this form, or you should want to construct symmetric matrix is this. Another way to make symmetric matrix is this. Take any matrix and do this, you get a symmetric matrix, right? Correct? Just like take any function and you do that, you get something like that, you get an even function or odd function, right? So you can do these things. So anyways, one can talk more about this later. So this is just an exercise in that, okay? All right, so if there are any questions, then you can tell me, but otherwise we will move on. Okay? Right. Yeah. So why don't you people try the next 6 and yeah, no. Yeah, so try question number 6. I'm just sharing the screen with you, so you can just try it, okay, first, and then we will just yeah, meet and do this. So just first try it on your own, okay? Yeah. So note down the question and then just try it, and then I will end the meeting and then you can do it. Yeah. So question 6, okay? Do you may not try 7, but just give me a second. Yeah, try 6. Yeah, I'll just come. Is it okay, this question? Yeah.
Yes, sir.
So is it done?
No.
No. So let us see. So if A is symmetric, right? Then what about A inverse? Is A inverse also symmetric? This is not difficult. This should be easy, right? So I mean, look, you know that A is equal to A transpose, right? You know that A is equal to A transpose. You want to look at A inverse and take its transpose, right? So again, you need a fact. This, it doesn't sound very good that we are always using facts, but just using this fact you can do, right? And then you know that this is A inverse because A is symmetric, so A transpose is A. So A inverse ka transpose, you again get A inverse. Okay? So again, you may want to try to prove this fact. It is not difficult. It will come from the facts that we have already stated. So that is the thing. Okay. You can also say this directly from the adjoint form, the formula of inverse, right? That is what is it formula? Adjugate of A by determinant of A. So if you show that adjugate of A is symmetric, if A is symmetric, that way also you can do. Okay, so try that, and I think the questions. This question is not difficult, right? Try this. From what discussion we have done, you should be able to do it. So try it. So try this question for homework. Okay, or maybe you can try. We will have a break, so we will need to have a break because of the Zoom thing. Okay. Yeah, so try this, and on the other side, we will just do the questions from last time. Okay, sorry, I have to take another break because of the Zoom. But yeah, in the break, you can try these questions. Okay? This other parts. Yeah, think about this. Yeah, I'm ending the meeting.